Okay, from this class onwards, we will be discussing about network models. So in the process, we will also be touching certain issues which concerns network models or which are related with network models. Uh, so before we move on to the core of the network models, there are certain things that I would like to repeat here. Say, for example, computer network. What is a computer network? Computer network is a combination of, never forget this, is a combination of hardware and software. Okay, so when these hardware and software are made to perform together, and we can make it perform or make it work together to send data from one place, from a source to a destination. So it is not just hardware. Sometimes so much emphasis is given to hardware that people forget the part software. The important part of software is which is played by the software. We cannot simply have a hardware only and then have a computer network, or we cannot have only a software only without the hardware. Okay, so it is a combination of hardware and software. In fact, when you talk about computers, anything that has to do with computers is a combination of hardware and software. Now, this hardware in a network, in a computer network, is a physical equipment or physical things which is responsible mainly for carrying signals. Okay, it carries or it transmits signals from point to point. So the actual electrical signals that is transmitted across the network is done by it's done through this hardware. On the other hand, software gives a sets of instructions. So you have a set of instruction or protocols which allows services from the network. It means you are able to perform complex things. You're able to perform different types of things with the help of software. And ultimately, it is the hardware that carries the electrical signals from point to point. For example, like solving mathematical problems with computer, if you are to do this with hardware only, that means for every operation, for every mathematical operations like plus, minus, uh, uh, multiplication, division, and so on. I mean, there's so many other mathematical operations are there. For every minor operation, you have to build uh, something that the hardware should be able to perform. Okay, so but when you are using software along with the hardware, one particular point which can be used to perform addition, subtraction, or more. So that is how important it is to have a software and hardware working together. For example, the task of sending an email, another example, from point to point in the world to another, uh, if it's to be done only with the hardware, then that is going to be really difficult, and it's going to be you will end up building a lot of hardware. So it is important that we have software and hardware working together in order to have a proper computer network. Okay, so that is when you have a computer network, then you can think of network models, different types of networks. So you have network models. So you can think of those models only after you put together hardware and software to function. Now, let us also touch some examples. I mean, like layer tasks. This is very important, layer tasks. So when we are actually sending or transmitting data from point A to point B, the way the transmission takes place is somewhat is layered, okay, is layered into different layers, so that common or the tasks which are similar are put together in one layer, and the tasks that way on both sides, on the sender side and the receiver side, common tasks are being put together, and that is called as a layer. So similarly, you may have multiple layers of different tasks. Now, here is an example of a partial which is being sent from one destination to the different destination. So here, the sender is sending the partial to a receiver. I think this we are very familiar with this kind of example, or a partial or a letter. In this case, I think it is a letter. So the letter is written, okay? Layer task example is sending letters. Now, a letter is written, so the sender writes the letter. After writing letter, she puts it in an envelope and drops in a mailbox. So that is kept together as one layer, because all of these things are performed by the sender. So in that sense, these are similar tasks: writing of letter, putting in an envelope, and dropping in the mailbox. So this is called higher layer, because higher layer means the layer which is closest to the users, what the user normally perform. So that is usually higher. When you go lower, lower is more of, the layers which are closest to the hardware, actual hardware of the network. So in this case, the sender writes a letter, puts in an envelope, drops a mailbox. So we call this one layer. Then what happened is that the letter is carried from the mailbox to the post office. So in our case, what happened is that a postman comes, check the mailbox, take the letter, collect the letter from the mailbox, and take it to the office. So this is done by the postman. Okay, so the postman or the postwomen perform this, and then that is kept as another layer. This in this case we keep it is kept as middle layer, because this first layer is about the users performing all those things. Second layer is a postman, a middleman who is performing all of those things, and finally the letter is delivered to a courier by the post office. So the post office will do what? Will sort out the letter according to the destination, whether it's going to Guwahati, whether it's going to Kolkata, whether it's going to somewhere else. So that letter, according to its destination, is being sorted out and put together most probably in a partial, okay, in a partial, and then that partial ultimately will be carried from source to destination, from point A to point B. Ultimately, that will be carried. So it may go by vehicles, by road, it may go by train, it may go by air, but it ultimately moves from one destination to the other destination. On the receiving end, what happened is that the letter, as I said, these, sorting out the letter and putting in a partial and sending it to destination is lower layer, because this is more concerned with the physical movement, okay? Which is more concerned about the physical movement of the letter from one source to another, whereas the higher layers are more about logical layers, okay, logical tasks, or in other words, that it does not exactly move the letter. The letters are not exactly moving from point A to point B. Rather, it is taking the help of this different layers. For example, we know that the postman is going to come and collect the letter from the mailbox. That is why we put it in the mailbox. The sender puts in the mailbox, and then the postman the postman ultimately delivers it to the post office, which is sorted, okay, and then it is sent. So the physical transmission or physical transportation takes place from source to destination only in this lowest layers. That is why it's called the lower layers. Now on the receiver side, the letter is delivered from the carrier. Carrier may be, as we said, maybe by train, road, or air. Okay, so whichever is done, so it is carried to, to the city or the whatever the location is. Then it is taken to the post office. So it goes to the post office, and the post office once again performs similar tasks. You will see that the sender and the receiver both will be performing similar tasks. So at the receiver side, the receiver, the sender was taking the letter from the postman and then sorting for his destination based on the address written on it. So accordingly, here also, the letter which come in a partial is being sorted again according to the destination, the actual address. Maybe it's a house number or a locality. So it is being sorted again. Then and the letter is carried from the post office to the mailbox. The postman does that again. So the middle layer, the postman comes, and this postman, and here we have at the delivery side, we have another postman who takes a letter from the post office and keep in the mailbox of the receiver. Okay, so we are imagining that they have a residential mailbox. Okay, where you keep, letters. So residential mailbox, because in India we have a mailbox, common mailbox. But in this case, we are assuming that the mailbox is located at the residence, and a postman collects letters from the residential mailbox. So the postman takes it to the actual location and deliver it to the mailbox. Then the receiver picks up the letter, removes from the envelope, and reads the letter. So what happens is that if you look at this, the process which has gone through from here to here has been on this side also, the exact procedure is being reversed. That is what we call a layer task. So we are grouping, as I said, common tasks into different layers. In this case, higher layer, middle layer, and lower layer. So this is what we call layered tasks. So most data communication models are built on this concept that every task is layered. All the common tasks are layered together and put it in a layer. Now, one of the model that we will be discussing here is the OSI model, Open System Interconnect model. Now, this model is proposed by International Standard Organization. In other words, I think we are familiar with this. It is called ISO. So, International Standard Organization. This organization is a multinational body which is established in 1947. I've already covered a little bit of this. So it is a worldwide agreement on international standard. That means countries comes together and agreed upon a standard. So there are various standards which this international standard organization is responsible for. There are standards for different types of automobile or hospitals. You will see that as you move around in the city, you will see that ISO standard so and so. So almost everything has this. Almost every kind of imaginable thing the standard is being given by the International Standard Organization. So what happened is that one of those standards which is proposed by the International ISO, International Standard Organization, is Open System Interconnect. So this was introduced in 1970, and it covers all aspects of network communications. Okay, so what they try to show is that, see, this is a model, this is a standard model where you can have network communication. It doesn't mean that all network communication should strictly takes place according to the this model. It is a proposal. Okay, so the organization which proposed is International Standard Organization, and the network communication they propose is OSI, Open System Interconnection. Now, this OSI is a set of protocols. Okay, as we said, a set of protocol is necessary in order in the network. So, a set of protocols that allows any two different, okay, this is very important, different systems to communicate regardless of their underlying architecture or logic of the hardware and software. That means the two system may be different in every way. For example, like the architecture, the logic of the hardware and the software, they may be different, but these set of protocols, which is called OSI, allows the two different systems to communicate even with their differences. So it is a model. This model is designed, model for designing. It is a proposal. This model is a guideline or a suggestion for designing a flexible, robust, and interoperable network architecture. So you flexible in the sense that you are able to keep in any different types of systems, robust in the sense that no, it will not come crashing down that easily, interoperable in the sense that even if they are different systems, they can still operate like they are the same system, because in computer network there is always a problem of interoperability. When you have two different systems, X and Y, okay, X and Y. For example, you have Android and Apple. Interoperability between the two becomes a problem in many cases. But these OSI models suggest that even if you have Android and Apple also, if you follow this OSI model, then the interoperability should not be a problem. So the model provides a basis for further exploring data communication. It's not only a guideline, it's not only a suggestion or a model, but it also points us to how to further explore, okay, how to further improve data communication. So this is what the OSI is about. Now, as we said in the beginning, that network models are basically layered tasks. So similarly, the OSI model also is a layer architecture. The way it is built, the model is suggested or proposed is based on different layers. So a message traveling from A to B have to pass through various intermediate nodes. Okay, so it is not that the device A, when it sends to device B, it should directly send to it. They may have to pass through some intermediate nodes which help pass on the message in between the two. So these nodes usually involves only the first three layers. Okay, so the nodes in most cases will involve only three layers. And layers related network functions are grouped together as layer, as we have said there. The related functions of the network are grouped together as a single layer. For example, application layer, here various functions are grouped together as application layer. Similarly, presentation layer, here also various functions are grouped together as a single layer. So it allows complete interoperability between incompatible systems. That is what we said. So even if the systems are incompatible, interoperability should not be a problem. As long as they follow this standard, they can still transmit data between these incompatible systems. Each layer calls the service of the layer below. That means this application layer takes the help of the presentation layer. The presentation layer takes the help of the session layer, and so on. Like in our sending letter analogy, that the sender takes that sender, writes a letter, puts an envelope, drop in a post box, is taking the help of the postman who is performing the task at the next layer. And the postman is taking the help of the post office, and so on, the post office and the transportation systems. So each layer is taking the help of the next layer. Now, controlled by a common series of rules and conventions called protocols. So this architecture is will have a series of rules and conventions. So when you have those rules that governs the network, we call that protocols. So communication between the processes on each machine in the corresponding layer is called peer-to-peer processes. For example, communication takes place between application to application layer, presentation to presentation layer, session to session layer. These kind of communication between the corresponding layer is called peer-to-peer process. Now, what is peer-to-peer process? Peer-to-peer process, communication is direct at the layer, but at the higher layer, communication moves down through the layer in the sending device A, and then up through the layer in the receiving devices. If you look at this, that in most cases, that application layer most probably will send the data to the presentation, and presentation will send the data to the session layer, and so on, and then transport layer. Ultimately, here only it will move to the movement takes place in towards the destination. So each layer in the sending device adds its own bits, okay, its own information to the stream of bits. If you have, let us say, this is the stream of bits. For example, the first layer add this 4 bits, and then this is the message, the actual message, for example. Then the next layer also, 8 bits. The next layer will also add some more bits along with these 2. Okay. So similarly, it pass on. It adds its own bit stream and pass it down to the layers just below. Only at layer 1, entire package, every bit that is added, and means application will add its own information or bits of data for the corresponding application layer on the receiving end for this purpose. In order to have this application layer communicates with this application layer. How does it communicate? By adding some additional bits, which is only for the consumption of this application, or only for the instruction for this application layer. It adds its own control bits or its own additional bits of information. Then the presentation layer also adds on top of this bits added by the application layer. The presentation layer also adds its own bits again, which is to be used by the presentation layer at the receiving side. Similarly, the session layer also adds to what is already being added. So that is how it is done. Then all of those big streams, along with all the additional information added by all these layers, is ultimately transmitted in the physical layer, which is the first layer. So at the receiving machine, the message is unpacked layer by layer. Each additional bit added in the sending device is used and removed by the corresponding layer. So every layer, as it goes out, the physical layer, then the data link layer, as it goes, whatever streams of bit which is added by the data link layer will be removed by the corresponding data link layer, and because it will use it, then remove it, then it will pass on to the network layer. Whatever additional bit which is added by network layer will be used by this network layer. In most cases, it might be instruction for this network layer. Then it will pass on the remaining, it will pass on to transport layer. Similarly, here also the transport, the additional bit which is added by the transport layer will be used by this transport layer and then pass on, and ultimately it will be left with only the streams of bit which is added by the application layer, which will be used by this application layer. And then ultimately, with the help of those additional bits, the streams of bit will be properly presented as it is meant to be delivered. Okay, as it is conceived here at the sending side, it will also be received here at the sending side with the help of all those things. That is what we call it peer-to-peer process. Now there is also, if you notice that there are interfaces between the layers. Okay, between the layers there are interfaces. So an interface between the adjacent layer below and above facilitate the passing of the data and network information down through the layer in a sending device and up through the layer in the receiving devices. So each interface defines information and a services a layer must provide to the layer above. So what happens is that there are interfaces. So these interfaces will go through, this. There is interface between application and presentation. Similarly, application and presentation. You know, whenever there is interface, that communication between the layers also takes place, and that is what exactly what is happening here. Then we comes to the organizational layer. There are all 7 layers to be 7 layers, and all of these 7 layers can be categorized into 3 groups. Okay, so this can be the first group. This itself is its own, and then this last 6. So we can call them 1, 2, 3 categories. We can divide them into 3 categories. The physical, data link, and network layers can be called network support layers. Okay, because these 3 layers, network, data link, and physical layers, deals with the all these 3 links, deals with the physical aspects of moving data from source to destination, from one point to another. So these 3 layers are basically concerned with the actual transmission of the physical data. Now the session layer, this one, the session layer, presentation layer, and the application layer can be considered as user support layers. Okay, user support layers, because this deals with the tasks like allowing interoperability among unrelated or incompatible software systems. Okay, so these can be considered as user support layers. And finally, the middle layer, the transport layer, links these 2 groups, the user support layer and network support layer, then the transport layer. Okay, so the job of the transport layer is that it ensures it links the 2 groups and ensures data transmitted by the lower layer are usable by the upper layer. So that is the job of the transport layer. So upper layers implements almost always in software. These user support layers are usually, in most cases, are purely software, whereas the lower layer are network support layers are usually a combination of hardware and software. Now, we did a little bit of encapsulation. Now, this is what happens. Encapsulation means that this is a data, okay? This is data. Then this data is being, one layer is adding a header, okay? Similarly, another layer adds another header, and so on and on. So as this layer adds here, this becomes part of the stream, okay, bits of stream. Then here the next layer adds another and then this layer also adds another bits of stream and so on. So the actual stream of data is completely encapsulated in all of this, throughout the layers. Okay, then ultimately all of those big streams with additional control bits or added bit streams will be transmitted, and accordingly, as we said, it will be used by the corresponding layers. Okay, we have with that we have come to the end of today's class. Thank you very much.